Hello everyone, here is Dr. Wasim for TBTOOL. Today I bring the tutorial from the TBTOOL tutorial series. It's about Synteny analysis. Within this analysis we can find different types of duplication in genome. So for this analysis we need some tools like FastStat, BLAST, merger for MCScanX wrapper, transformat for microsynteny view, text block, extract and advanced circus. In addition, some other softwares we also need, and I will tell you during the tutorial. So how to visualize the circus. So it's available under the graphics tab. Go to graphics tab and then choose advanced circus. So it looks like this. So we need 3 files. First one is the chromosome length file. Second file is the gene linked file. These are the two genes pair that are duplicate of each other or duplicate. So we need this. And then how to prepare all these files. So we can prepare these files through different tools available in TBTOOL, but for this we need 3 different types of files. First one is the genome file, second is the protein file of that genome, and third is the GFF, which is the genome coordinates about the different genes on the proteins. So these 3 files you can download from your model or organism database. First one is the chromosome length. So how we can find the chromosome length? There are 2 ways to find the chromosome length. The first one is you can get this information from the genome database, and the second you can use TBTOOL to extract this information. So let's begin how to get this using TBTOOL. In TBTOOL there is one tool which is called FastStat, which is available under the sequence toolkit. You can access it following this sequence toolkit FastStat tool, and under that tab you can find it FastStat. So for that you need the genome data file of your model organism you are working on. So when you open it, looks like this. It contains one tab for input and then another tab for output. Just put your files, input files there, genome file in input section, and give it an output pathway and then press start. In output you will get a file like this which contains different columns. The first column is about the gene, chromosome ID, then simplified ID, description, length, and blah blah blah, different from, but we need these 2 columns. The first one is the simple ID and the length. These are the chromosomes and their corresponding lengths. So we can format it like this in the 2 columns. The first column for gene ID and the second column for simplified ID for chromosome, and the second column for these chromosomes length. In the next one is we need the link of our duplicate gene pair. So how we can get this? It contains several steps. The first step is the BLAST. You can access the BLAST tab under the BLAST menu, BLAST GUI wrapper, and then go to several sequence to big file. So for this the requirement is the peptide sequence in the FASTA format. So how you can do this? If when you open you will get the preview like this, and it contains these 5 panels where you need to put different information. In the first one and then second one you need to put your peptide file here, same peptide file, because we are going to BLAST peptide itself, so both files should be same. Then here you can choose table view, and then change these 2 number of hits and the number of alignments to 5 Here by default there are 500 and 250. You should change it to 5. Then give it output pathway with your name of interest, any name you want to give it, and then press start. After some time it will give you the output like this. You will get an output with extension blast. In the next step you should open the merger for MCScan. It's available under the graphics menu. Go to graphics, then Synteny visualization, and then you can find the text merger for MCScanX. So the required data for, or the file for this, is the GFF file of our genome. So in preview it looks like this. In the first input file list you should put your GFF file, and then from merger mode you choose GTF, GFF2, SIMGXF, and then give it output pathway with any name you want, and then press start. After that, the output you got from the previous step and the blast file you got from the blast step, these two files are then put in MCScan wrapper. MCScan wrapper contain three file pathways. In the here you should input blast, then GFF and then output directory, and then press start. In the first step, set input.blast file, you put the file generated in the blast step, and set input.gff file, put the file that is generated from merger for MCScan, and then again give it to output pathway, and then press start. After some time you will get your result with extensions HTML, Collinearity and Tandem. These three files will be generated by MCX wrapper. So in the next step we are going to detect the gene pairs. For this the tool is available under the same tab, graphics, Synteny visualization, then press text merger ScanX. Then how we can use the merger for ScanX. So the required files are collinearity file generated in MCScanX wrapper. So file merger for MCScanX looks like this. It contains the first step for set input file list. Here you input the file generated in MCScanX wrapper, and then you choose merger mode collinear, give it output pathway, and then press start. This time it will give you a file named gene pair, which contains the pair of genes that are duplicate each other. The next step is the transformat for the micro-Synteny view. It is also available under the same graphics tab. You can access it, and the required files for it are the gene pair file, which is generated in the previous step, and the GFF file which is generated by the merger for MCScanX. So when you open it, it looks like this, and here you choose gene pair, and then input your file, which is a gene pair file from last step, and a GFF file which is generated in the merger for MCScan, and then give it output pathway and press start. After that you will get a file with some information and linked region.tab. The next step is about, so we have now chromosome length and set linked in gene pair set links. So when we put these two files here, chromosome length and the gene pair, and then press show my circus plot, we will get the preview like this. You can see here we have chromosomes, and in the middle we will get all the gene pairs that are duplicate with different regions of different chromosomes. So we can change, because you see here it's localized in the middle, we can expand it towards the chromosomes. So we can press show dialog box, and then here we can change link position to 79 and then refresh the graph, and then we will see that our gene pair will be expanded up to the chromosomes. So here you see these all are in not in a different color, or not in a not properly previewed. So we want to make them visible. So for this we need to do some more analysis. The first one is the text block extract. This is used for highlighting our genes, pair gene duplication pair in Synteny diagram. So we need this information from gene pair. So file required are the gene pair file, which is generated in detecting gene pair steps, and the gene list. This gene list is our list of gene of interest we want to visualize on our Synteny plot. So here is the view how you can do this. So to use text block extractor, you go to other, table text manipulator, and then select text block extractor. It looks like this. First is input, table file tab, output, table file, set condition text, and then different conditions or the different parameters, and then press start. So for the first one, set input table is the gene pair file, which is generated in detecting gene pair. Insert here, and then here we will put the genes of our interest, the genes we want to visualize in Synteny, and then we choose some parameters like contain, extract, give it output pathway, and then press start. After some times it will generate a file, which is then further used in file transformat for Synteny. Here we will choose format is the gene pair, which is we got from table block extract or filter step, and then we will input a table file. This table file is the gene pair file, which we got from the last step, and the GFF file, which again we got from the merger for MCScanX step. Give it output pathway, and then press start. So the output from that step, it looks like this. It contains two columns, and the next two columns are corresponding to the gene start, and then the next pair to the first gene, it's start, and it's like this. So we will insert another column after the gene pair like this, and in that column we will insert the color values. Here I insert the color value for red color for our gene duplication pair, and then save it this file. So now we have a gene length file, genomic feature files, and gene pair linked file. So we insert all these three files here, and then press show my circus plot. So you can see it looks like this. By putting this set input genome features, it highlights our genes our gene of interest. It highlight which gene is duplicated from one chromosome to the other chromosome. Like here, from chromosome 2, there are 2, 3, 4, 5, 6 genes that are duplicated with chromosome of an unknown, chromosome 7, and chromosome 4. But here you see the information that like which gene is duplicated with which gene on a chromosome. So in order to visualize, we need some further analysis, like how to make the gene name visible. For this we need a table manipulator, which is available in TBTOOLS, and the GFF file, which we generated in merger for MCScanX. So the table manipulator, we can access it from the other table text file manipulator, table row manipulate. From here we can access it. When we open, it looks like this. Here is the input file. The input file is the GFF file. Our GFF file we have generated in merger for MCScanX step. So when we insert this file here, it will pop up like this. So here we will choose the column 1 and then press select done. When we do it like this, here the column 1 will appear. It means the first column, the column 1 is selected. Then we will input the gene list ID. This gene list ID must be same list ID that we have put in the step text block extract step. After that we will put the output table file. Here is the output pathway. From other parameters, choose match extract and then press start. The output file looks like this. Now it contains an additional column here. Like in our last step, if you remember, here you can see we have just chromosome number, chromosome start position, end position. But after performing this step, it contains gene ID as well. So now we can modify this file in a two way. The first one is we should add the color values. It depends on you which type of color you want for your gene pair. You can Google it for different colors. Here you can see the gene ID list. You can replace this gene ID list with gene name you want, or you given according to your procedure, and then save this file. After that, replace this file, set input genome feature file that we have previously put, but we didn't get the gene name. So just replace this one and keep the other files, and then press show my circus plot. After that you will see your circus plot like this. So now this time the gene names appear, and if you name with different colors, then the different colors link and the gene names will appear. Like here I give the green color to the gene 11 and the gene 01. So both of these genes become green and their link also become the green, while for the remaining remain red. So if you want to modify further, did some modification in the preview, you can just go to the show control dialog which appear above this tab. When you press show my circus plot, it will appear at the top. Just press this dialog and then you will see a menu. In this menu you can do different type of changes, like change the chromosome label, font, color, similarly the gene label, name, font. Did some changes in the chromosome length, width, change in that. Like this you can change different types of changes. So this is all for today tutorial. Thank you for watching. Please do like, comment and share this video. See you next time with another tutorial. Bye bye.